Hi everyone, welcome back to Art of the Part. In these next few videos, we're going to cover the Ye Olde Pop Topper case study, which is going to be this bottle opener here that we see on the screen. Now, I'm going to give you this either in class or via the Google Drive, but this is a write-up for the case study, and we're going to start off by using or referencing this rough sketch or a DXF file. And from there, we're going to make a 3D part model from it. And we'll create a couple configurations and apply different materials, and we'll compare and contrast those materials by using a finite element analysis, or in SolidWorks it's called SolidWorks simulation. Then we'll make a work holding assembly for the second operation so it can be machined, and then we'll wrap up the case study by actually machining the part in class. So that being said, you'll be able to download a handful of files from the Google Drive and just put them in a folder somewhere. I have one on my computer already, but we'll see a file for a PDF, which is going to be the blueprint. This should be, you can open this on any device. And then we also have a file for, and I'll just minimize this, the DXF, which if you have SolidWorks downloaded on your computer, you should have eDrawings downloaded as well. You can also get this app on your phone, and you can send files to and from customers or clients or your boss, and they can review drawings on the go as well. But this is an eDrawings file. If you look here at the type, it's a DXF file. If I double click on this, it's going to open up a different application. And what's convenient about this application is different from the PDF is I can actually take some measurements of the geometry that I see in front of me. Now, I know I have this all dimensioned as a blueprint, but if I, for instance, didn't have a dimension on something and I wanted to see what that was, I could click down here in the bottom left-hand corner. It says measure, and I have the little measuring tape. I can go ahead and click on one edge or a point to another edge or a point, and it'll tell me what that distance is. Now, herein lies a little bit of a conundrum. We have a 156 dimension listed on the print, and we have 313 listed here on the measurement. Now, which one of those is correct? Well, we'll have to refer to the title block to determine that. And if we see down here in the bottom right-hand corner, we should have a 2:1 reference for the scale, which means that the blueprint or the geometry that we're seeing on the blueprint is twice as big as it should be. Now, that isn't a bad thing. It's actually probably helpful for whoever's making the drawing because given the size of the part, it's 2.5 inches. And if this was a 1:1 scale, we probably wouldn't be able to fit all of these different dimensions on here. So we've taken advantage of the fact that we can actually increase the size of the scale and put all of the dimensions in one view instead of having to split it up between like a top view or front view and then a detail view and just trying to reference all these different areas of the print. So we'll cover that a little bit more in detail later, but just keep in mind that when we import this into a 3D model, we'll actually have to scale, and then as likewise, we'll have to move onto the origin and then set it up to be referenced for a 3D model. So I'm just going to close out of this eDrawings viewer, and I'm also going to close down out of this little part here, and we'll start over fresh. So there's a couple ways that we can process a DXF file or a DWG file. And the first way that we can do this is by opening it up inside SolidWorks by going up to File, Open, and then we can find the file location. And we might have trouble finding the DXF file in the opening command because maybe we might be set to open or filter from parts, assemblies, or drawings only. So we can hit this drop-down menu on the bottom right-hand corner where it says either SLD or PTs or all SolidWorks files, but we can either change it to all files and we can find the DXF or the DWG that way, or if we hit the drop-down menu, we can filter it just by AutoCAD, Autodesk Files, DWG, DXF. And I just want to make mention here that the difference between DWGs and DXFs are very slim. DWGs are more native and more responsive to Autodesk products like AutoCAD 2D, whereas DXF files are more universally accepted between all CAD platforms. So I tend to lean towards DXF files whenever I'm sending or receiving files. So if I just filter by this, I can find that Ye Olde Pop Topper and then I can hit open. And I'm going to show you two different ways to do this. The first way is, in my opinion, bad practice. So maybe don't follow along step by step on your screen, and maybe just follow what I'm doing by watching. So in this instance, it's going to open up this DXF DWG import, and it's going to ask us where to import this. And the two options are either to import it to a 2D drawing sheet file or a 3D part file. Now, if we click on the 2D drawing sheet file, it's going to step us through a couple windows. It's going to say, hey, what layers do we want to import? It's also going to give us an option to select what plane we're going to import. Now, this really isn't going to help us because if we're importing it into a 2D drawing file in SolidWorks, there's really only one plane that we can reference. So that's not going to matter. And if we hit next and finish, next, and then we can see that we can import as inches, a specific paper size, and then we can also determine the drawing sheet scale. So now I can hit finish. And I've already drawn this inside of SolidWorks. It's giving me this error. You can hit close. It's just telling me that there's different fonts that are being used. That's fine. I've already drawn this inside SolidWorks, so it's actually importing one-to-one onto a sheet file. But we can see here that I can click on this geometry or this text file and I can delete it. But the problem here is I want to eventually make a 3D file from the DXF file. So if I was going to process this, I would have to select the geometry that I actually want to copy or cut out of this, and then go to edit, copy or cut, and then start a new file, and then paste it into the part file itself, and then I can start extruding from it. I don't really subscribe to that theory of post-processing, so I'm going to actually close out of this file and I'm going to show you how I would approach this and what I think is best practice. Now, this is all personal preference and it's just dependent on how you deal with DXF files. So I'm going to encourage us all to start referencing the File Explorer rather than going to File Open. So if we go into that File Explorer and we find the file location, we can go ahead and with the left mouse button, click, hold, drag, and drop out here in the SolidWorks home screen. And what this will do is will automatically open the DXF DWG import. And instead of clicking that first option, we're going to click on the second option. So import import to a new part as a 2D sketch. Now what this is going to do is it's going to make a 3D part model file, which is going to be helpful because we can start extruding from the geometry that we brought in. So we can see that it says 2D sketch, and there's an option underneath it that says import as reference. The 3D curves and models are helpful if you do have 3D geometry, but in this instance it's a 2D sketch. I only have to worry about the 2D, and I would encourage you to just deselect this import as reference because you'll eventually have to go into that instance into the feature tree and then make it a sketch, removing it from a reference to be used. So go ahead and deselect the import as reference and then hit next. So then we have a very similar window here. This is a little bit more reactive in that, or responsive in that we can actually choose different planes to actually import this onto. But for instance, the front plane and the back plane, they're really not going to be helpful. Likewise, the right plane, because it's going to compress everything to just one single line. Not going to be able to get any information out of that. So we'll just stick to the top plane here. And then we have the option to select different layers. So if I click on the selected layers from all layers, so we can hit selected layers, we can toggle through some of these different layers and choose what we actually want to import. And I've had lots of experience with DXF files, especially legacy files where there's like hundreds of different dimensions and notes and other callouts that are going to start slowing down your computer. So if we're just trying to process this as a strictly 3D file, let's go ahead and deselect some of the information that's not really going to be helpful, because I do have the PDF in the background here that I can always reference. And I also have that DXF that I can open up in eDrawings that I can always reference. So for instance, I can deselect the logo, I can deselect the format, which is the notes there, title block and border. That's just going to slow down my computer if I import that with the part file itself, and then the sheet dimensions, don't really need those, cross-section, revision table, and all I'm left with now is the part. So let's just have the part selected, hit next, and then it's going to give us an option for merge points closer than 1,000ths. And this is helpful, especially with like newer files, in that if there's a gap in between, say like a line and then a tangent arc, it'll try to merge those and make them tangent. But this could be a problem with legacy files like pre-2010, where there might be some rounding errors during the export process, in that it'll create a gap that's too big, or it'll try to force the tangency and it'll actually like bulge or pop out some of the radius or radii. So if you come across that, maybe try deselecting this merge points closer than, but I usually just leave this on, and especially I just exported this earlier today, this should be a relevant file. So I can just hit finish, and this is saying, do you want to explode the options? So we're going to hit yes. And now we should be prompted with a sketch that we're currently in, and then two views that were on the part layer of the DXF that we had. So what we're going to eventually have to do here is we're going to have to scale this down, because I was talking about earlier, the drawing itself is 2:1. And then we're also going to get rid of this geometry here, because if I try to extrude or reference this, it's not really going to work because it's at an isometric view. So first and foremost, let's get used to selecting with the selection box or the bounding box. So what we can do is, using the left mouse button, we can click and we can just drag and hold a box over a selection. So I can just drag over this isometric view here. You see how the sketch changed colors a little bit, and it went to a lighter blue, and it's just telling me that I've selected that geometry. And then I can hit the delete key on my keyboard to get rid of it. So I'm going to go ahead and hit delete and get rid of it. So what we're going to do now is we're going to investigate the geometry that we just imported and make sure that it did import as 2:1 and not 1:1. So we're going to use the evaluate tab. So up here in the ribbon bar, we're going to hit evaluate. And then we're going to use, just like how we had in the e-drawings, the tape measure, or this measure option. So we can click on this and we can select, just like how we did before, a point to a line, and we can see the value of that. So that's reading as 0.3125. In reality, that should be 0.15625. So it's double the size of what I truly want this part to be. So I'll have to go ahead and scale all of this geometry down to an appropriate size. So that said, let's go ahead and use the selection box or the bounding box, just like how we did before, to delete the isometric view. So we'll click over here, top left, and we'll drag a box over the geometry so it's all selected. And then we're going to go hop over here to the Sketch tab, and then we're going to look for the Move Entities option. And we're not going to click on Move Entities, we're actually going to hit the drop-down menu of it, and we're going to look for Scale Entities. So underneath Move Entities, we're going to find Scale Entities. And what we can do is we can scale this according to our needs. So for example, if I have a part that was drawn in millimeters and I had to scale it down to inches, I could choose a reference point. So in this blue box here, I could choose that. So in the instance of, or the example of the scaling from millimeters to inches, I could type in the value 1 divided by 25.4. And that would scale it at a rate of 0.03937, which is our scale factor from inches to millimeters. Now, we're not going that extreme. We're actually just going to go to 1 divided by 2, which is half the size. So again, all I did was I selected a point to reference, so that was going to use the center point of this through hole, and it was going to scale all of the geometry that was selected by half. So then I'll hit the green check mark. And I can investigate that once again. I'll hit the green check mark to get out, or hit the escape key. And I'll go into the Evaluate tab, and I'll use the Measure tool again. I'll zoom in, and I'll grab that point to that edge. And hey, look, it's reading 0.15625, which is the 1:1 scale that I'm looking for. So now I have a part that is scaled correctly, but it's pretty far off the origin, which isn't going to be very helpful if I wanted to eventually write G-code for this or import this into Mastercam. So what I'll have to do is I'll have to, once again, select all of my geometry, and I can do a quick command of this by hitting Control-A. That'll select everything on my screen, which is helpful if I'm only dealing with the geometry, but if there's multiple pieces of geometry, it'll select everything that's in your viewport here. So I'm going to just hop back over here with all of my geometry selected to the Sketch tab, and then where I found the scale entities was under Move Entities. I can just use Move Entities here. I can hit the drop-down menu and I can hit Move Entities. And what we're going to do here is we're going to move this point to that origin. So go ahead and choose From To in the parameters here in the Move Entities Properties bar. And I'm going to select that point. And once you select that point, you'll notice that the geometry or the sketch is all going to be tied to your mouse. And I can drop this anywhere I want it to, but what I'm going to do is I'm going to zoom in here on the origin, and you'll feel the geometry snap to the origin from that center point that we were referencing. So I'm just going to click on that center point. And it's still tied to your mouse because it's wondering if you want to move it even further. I'm actually done with this command, so I can hit the Escape key. And then you'll notice that it deselected everything, but it did move my part to the origin. So one thing that we'll have to establish now is relocating the origin of this part to the top right-hand corner, because it'll be a lot easier for us to write G-code to that instead of referencing it from this center hole and then going up that distance and then starting to going around that way. So we're going to, once again, reference the Evaluate tab, and we're going to click on the Measure tool. And once we click on that Measure tool, we're going to click on that center point, and we're going to click on the top edge here, and we're going to get a value of 0.21875. And I know that this is a perfect circle here, and I'm at the center point of it, so in Y, I'm 0.21875, and in X, I'm 0.21875 from the center mark of this hole. So I'm just going to have to shift this down so that the intersection of this line and the intersection of this quadrant are right here. And an easy way to do that is if we take that measurement, we should see a value that pops up here in that distance. So it says 0.21875. So I'm going to click on that, and what it's going to do is it's going to select that dimension, and I'm going to use the quick command key of copy. So I'm going to hit Control, I'm going to hold down Control, and then click on C. So Control C, that's going to copy that dimension and put it on my clipboard. So now, when I want to move this, I can also write down this dimension too and keep it in the background somewhere, but if it's on my clipboard, I can go and select all this geometry once again by hitting Control A, or selecting it using the bounding box, going over to the Sketch tab, going into Move Entities once again, and instead of referencing a point, I can use X and Y. So I can actually shift in X and Y using determined or predetermined values. So in this instance, I had 0.21875 that I measured. If I wrote that down, I can type that in X and Y to shift it down and to the left, or I can just select this 000 here, and I can hit Control V. It's actually going to paste my value there. If I click on the next instance from X to Y, you'll notice that it shifts. It shifted to the right when in reality I wanted to shift it to the left, so all I have to do is put a negative symbol in front of that. And then same thing for Y. I'll paste this, it's going to be positive, so it's going to move up. So we just have to put a negative value in front of it. And what that did is it just reestablished the origin to be at the top right-hand corner of the part. So it'll just be a lot easier for us to write G-code going around. So I can just go straight down and follow it around instead of having to offset it and then go all the way around once again. So I'll hit the green check mark. This is also very helpful when we're dealing with 5-axis because I want to rotate the part around the top edge here to engrave the name, which it says here on the blueprint, engrave name. So if I had to offset that distance, then do the rotation. It's just one extra step. I'm saving myself the step by just shifting it down. So there's two ways that we can use the move entities command. I can do from to, like I did with the first step, where I moved it from the center point to the origin, or I can do X and Y by using predetermined values and either typing them in or pasting them in and using the positive or negative symbol to orientate it the way that I want it to. So I'm going to hit the green check mark. I'm going to end the lesson right there, and we're going to pick up in the next video and actually start creating 3D geometry from this DXF that we just positioned from the import. So I'll see you in the next video, and take it easy.